of discovery lies a profound mystery. For some reason, on an unexceptional planet orbiting a run-of-the-mill star, a species of organism evolved that managed to work out how the world is put together. That surely tells us something deeply significant about our place in the natural order. But what? Chapter 2. The Search for the Key to the Universe. It's impossible to look up at the night sky and not be struck by the grandeur and beauty of the vista, the sweeping arc of the Milky Way, the myriad twinkling stars, the insistent, steadfast brightness of the planets. The sheer vastness and complexity are overwhelming. For millennia after millennia, our ancestors observed the same sky and struggled to make sense of what they saw. What was the key to understanding it? How did the cosmos come to exist? What was the place of human beings in the grand scheme of things? For many societies, making sense of the heavens was not merely a philosophical or spiritual quest, it was also a practical necessity. Knowing the movement of heavenly objects was critical for human well-being, not just for navigation, but seasonal migration, crop growing, and timekeeping. Our distant ancestors' preoccupation with the cycles of the sun, moon, and planets is obvious from the megalithic structures they built, some deliberately designed to align with astronomical events often imbued with divine significance and marked by elaborate ceremonies. The sky was regarded as the realm of supernatural agents. In some cultures, the sun, moon, and planets themselves were treated as gods. But the regularities evident in the movement of astronomical bodies suggested a very different concept of the heavens, not as the playground of the gods, but a mechanism, an elaborate system of moving parts. Once this notion became established, precision measurements were crucial to determine how the mechanism was organized and regulated. Arithmetic and geometry were now essential skills. Astronomers became powerful and important figures in society alongside priests and emperors. Their careful measurements and analysis gradually revealed order and harmony, number and form in the celestial activity. Many theoretical models were constructed over the centuries. A well-known distillation of earlier ideas was compiled by the 2nd century CE Greek astronomer Claudius Ptolemaeus. Ptolemaic cosmology featured a complicated system of nested spheres turning around the Earth at different speeds. The mechanistic models of the universe were on the right track, but the theological dimension was never eliminated entirely. There was ever the vexatious issue of origins. How did the great cosmic contraption come to exist in the first place? Was there a prime mover who set the complex mechanism in motion? A supernatural creator who conjured order out of chaos? A god who made the universe from nothing? No attempt was made in these early models to link the motion of astronomical objects with the motion of material bodies on Earth. Heaven and Earth, each filled with movement, remained separate domains. This view persisted through much of the medieval period until the 17th century. Then, suddenly, humankind's understanding of the universe was transformed. A small band of visionary natural philosophers came to realize that the key to the universe was not to be found in divine agency, nor in the geometry of the cosmic architecture itself. Rather, it resides in laws of nature that transcend the physical world and occupy an abstract plane, invisible to the senses, but nevertheless within the grasp of human reason. Number and form, beloved of ancient philosophers, are manifested not just in specific physical objects and systems, but interwoven into the very laws of nature themselves, forming a mosaic of subtle patterns encrypted in a kind of cosmic code. It was a stunning conceptual pivot, marking a transition from mere description of the world to explanation. The quantum leap in comprehension accompanying this transition was poetically expressed by Galileo in 1632. The great book of nature is written in the language of mathematics, without which one wonders.